Iodine tetrachloride ion. First, we'll draw the Lewis dot structure. First, we need to determine the total number of valence electrons. Iodine has 7 valence electrons. Chlorine also has 7 valence electrons. So we have iodine plus 4 chlorine atoms plus it's an ion, so we have 1 extra electron for the negative charge, which gives us a total of 36 electrons. Next, we determine the number of electron pairs, and that would be by dividing 36 divided by 2, which gives us 18 electron pairs. Now we can draw the Lewis dot structure. So iodine will be our central atom, and then we will have chlorine, on the outside. Now we have to fill in our electrons. So we have 18 pairs. We've used 4 in the bonds between iodine and chlorine. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 pairs, which still leaves us with 2 pairs. And those will be lone pairs on the iodine atom. So that is our Lewis dot structure. Lastly, we need to show that it is an ion. So we put brackets and the negative charge. And that is our Lewis dot structure for iodine tetrachloride. To draw the VESPR structure for iodine tetrachloride, we need to take a look at the Lewis dot structure that we drew in the previous slide. From this, we can determine what we need in order to draw the VESPR structure. So 1 we need to count the bonding pairs and the lone pairs of electrons. So the bonding pairs, we have 1, 2, 3, 4 bonding pairs. And then lone pairs, we have 1, 2 lone pairs on the central atom. That tells us we have total electron pairs of 6. Which means our VESPR structure will be octahedral. And because we have 2 lone pairs with 4 bonding pairs, it means it is square planar. So now we draw our VESPR structure for iodine tetrachloride. Iodine is still our central atom. Then we'll draw a square of chlorides. And now for our bonds, we will draw wedges to our bottom 2 chlorides and dashes to our top 2. We also need to draw, now we'll include our electrons. And we have 2 lone pairs, and because this is octahedral, one pair will go on top of the iodine, the other will go on the bottom. Then we just need to draw the lines to show our plane. And then we finish it off with naming the angles. And in this case, all angles are 90 degrees. And our brackets to show that it's an ion. So that is our VESPR structure for iodine tetrachloride. This is the 3D model that I built of the iodine tetrachloride ion. Using Mole's editor, this is the iodine tetrachloride ion. The only things not shown in this picture are the two lone pair ions. However, you can see from this depiction that the chloride atoms are in a square planar form around the iodine atom. In this drawing from the VESPR app, this is a better drawing of the iodine tetrachloride ion. It shows the octahedral shape with a square planar formation of the chloride atoms and the two lone pair atoms which complete the octahedral shape.